Right? Good morning, students. So, in the last class, we started a chapter called Atoms, right? So, in that introduction part, we have seen first who started Dalton, right? He failed, and again who came J.J. Thomson, and we discussed what he did. So, what are the failures and the continuation of that? So, we have to see now. Okay. So, yesterday, what is the last topic we discussed about the J.J. Thomson? J. Thomson, what he did actually, he discovered electron in 1897. And what is the disadvantage? He discovered electron, but he didn't give the magnitude of the electron. He said electron is there, electron will be negative in charge, and atom is neutral. All those things we have seen. Atom is neutral, and positive charge. Matter what is there inside the atom is positive charge, and inside electrons will be there, that is of negative charge. So positive and negative as a whole, he said atom is neutral. Okay, and then what we discussed about the specific charge, experiment about the specific charge, right? So now one more experiment it is there after J.J. Thomson. Already we have seen that. So who discovered the magnitude of the charge and how they discovered magnitude of the charge? What is the formula of that? Very important. We have to see now. So that experiment we call as oil drop experiment. Oil drop experiment developed by whom? Already we discussed yesterday. So developed by Robert Millikan. Developed by Milikan and Fletcher. Okay, so developed by Milikan and Fletcher. So Robert Millikan and Harley Fletcher. So just I have written Millikan and Fletcher. Is that okay? So what they did an experiment on the oil, why only the oil at all. We'll see now. Okay, so try to understand the situation. What they did first. So generally I will tell first what they did and how they calculated the magnitude of the charge. Then we'll discuss everything what is required for you. Okay, so first we'll see according to them, according to the basic thing what they did and how they got that magnitude of the charge. Concentrate, very interesting. So they considered two chambers first. Two chambers, right? Draw after me, don't draw with me, okay? So some changes are there, okay? Right? So in the first chamber, they connected with an atomizer. So this is an atomizer. So what do you mean by atomizer? So first year fluids, I think we discussed about this atomizers now. If you press this bubble, then what will happen? The water drops or any liquid drops will enter into this chamber 1. Clear about that point? To the chamber 1, if you press this, it will come out due to the pressure difference. Due to the pressure difference, we studied in 11 fluids. Due to the pressure difference, if we press this bulb type thing, what will happen? The fluid will enter. So we call it as atomizer, right? So now assume the oil drops came from this atomizer, right? It is falling in this direction. Now this chamber we have to divide into two parts of concentrate. So how they divided is they placed a plate here which is having a very small gap. Which is having what? A very small gap. In that small gap, what should happen? The oil should enter into the second chamber. So in the second chamber, what they did is they placed another plate. Okay, so this is of positive charge plate. They placed here, and this is of the negative charge plate. They placed here. So what we have to calculate now? We have to calculate the magnitude of the charge. How they calculated, try to think about that. So try to understand the experiment. And final result is very important, and how we'll get the final result also important for the competitive exams. Okay, so right. So if you press this, what will happen? The oil drops will enter. Change the color. Right? So oil drops will enter. See. So if we press this, so this oil drops, what will happen? They will enter. With some speed they will enter. Right? Okay. So now from this what will happen? Due to the small gap they will come like this. Right? So now what they did is, try to understand, what they did is whenever the drops are coming here from one end, they send X-rays, powerful rays, whatever it might be. So a particular wavelength of X-rays they have sent from here. Particular wavelength. So in some books, some standard books, they won't mention this directly. They will consider the oil drops, and by coming this due to a process, this will be charged. So in some standard books, they won't give these rays of particular wavelength. So directly, what they will tell by coming, what happened? So the oils will be collided or not. Now, due to the friction, they will be ionized. They will be charged. They said like that, but we can consider any rays. Due to this rays, what will happen? The rays will come here. So this is the external process. What I consider. Try to understand point by point. Okay. So if I send these rays, then what will happen? These rays, after striking these drops, what will happen? The drops get some charge. That is the process. The drops get ionized. The drops get some charge. Oil drops get some charge. It's an experiment. Mind you, okay? So rays came, so it strikes the drops. What happened? It gets ionized, it gets charges. So now try to understand. These drops again are coming here. Now at the other side, he placed a microscope or a telescope to see. Okay? So from here he is watching. From here he is watching. Right? So he is watching by microscope. Experiment will be very interesting. Give me 2 minutes time. By microscope, he is watching what will happen. Right? So what will happen? X-rays came from here and they get ionized, they get charged. So after getting charged, still they are coming down. Now they did something. So what they did is they connected this positive plate and the negative plate to an voltmeter, to a variable voltage. Voltmeter in the sense just it will measure, right? Now we have to vary. We have to vary the voltage, right? We have to vary the voltage by using some device. So they varied the voltage between these two. Between these two plates, they varied the voltage. If voltage varies, electric field varies. If electric field varies, the behavior of the drops varies. Clear about the point? If voltage varies, electric field varies between the plates. If electric field varies, then the behavior of the drops varies. This is the major thing. That's what you have to understand about the construction part. Then we will see everything. Clear about that? So, consider this is chamber 1 and this is chamber 2. So, what is the thing we did up to now? So, we considered an atomizer. So, we pressed the bulb. What happened? So, the oil drops entered inside. So, if they entered inside due to some process, don't worry about always X-rays or due to some process. They did some process here, and what happened to these oil drops? They get charged. What charge is that? They get charged. Now here positive plate and negative plate they can say, and it is connected to a variable battery. For example, we can vary the potential. If you vary the potential, electric field varies. If electric field varies, what he observes from the microscope is the behavior of the drops varied. Sometimes the drop went downwards, sometimes the drop went upwards, sometimes the drop didn't go anywhere, it is at rest. So due to the different cases, they wrote some equations and they solved, they got the charge formula. Due to that formula, we can calculate the magnitude. Clear about that? Now I am not concentrating first about that formula, try to understand what they did. Now, concentrate. I didn't apply any field. First point. So without applying any voltage, without applying voltage. So without applying the voltage, what consider only one drop. So here I have shown many drops. Consider only one drop. Okay. So consider only one drop is coming down. So you can draw that. Don't worry. So I am considering only one drop, which is charge. What type of charge now? Due to this process, what will happen is the negative charge I am considering. The charge of the drop due to that some process. What happened? Negative charge is there on the drop. Now the drop is there. Of what charge? Of negative charge. Only one drop I am considering. Can I draw it black? Right? So only one drop I am considering. I zoomed the drop and I have drawn like this. So clear? So this is the drop. So how this drop will behave under different situations we have to discuss now. So without applying any voltage, we'll go a little fast. Without applying any voltage, without applying what they did, general thing I am telling, then in depth we will see later. Okay, it will take mostly half an hour. Don't worry about that. So try to understand the point. So consider negative charge, negative drop, negative charge drop. So without applying any voltage, what will happen? It will move downwards. Only gravity will act. Only gravity will act. We know that this is the drop again. So only gravity will act. With that gravity, what will happen? It will move downwards. Okay, they observed. We know that. So long back they did. They don't know that also. So they observed without applying anything. So gravity. Okay, gravity is acted. So force of gravity is there. So it is acting downwards. Okay. Now they vary the potential. Try to understand the thing. They vary the potential. Clear? Next step. I'll write here only. So if you want, you can write here. Without applying the voltage, what will happen? Only gravity will be there on the drop. Then it will move downwards. Then it will move downwards. Clear about that point? Now, second point. So we applied the voltage. We applied voltage. So if voltage is applied, then what will happen? Electric field will be developed. I draw the free body diagram now. So gravity will act downwards, we know. And how the electric field will be? Positive to negative. That's how the electric field always from higher potential to lower potential. But now negative charge to drop. So electric field direction will be upwards. Now try to understand the thing. Try to understand the thing. Okay. So first they varied from zero. Voltage from zero. Slowly they are increasing. Electric field slowly it is down. Initially, which direction it is moving? Downwards. So initially, from the microscope you are seeing. Assume that. Okay. So we are seeing from the microscope, and I am varying the voltage. So initially the drop is moving downwards. Voltage initially zero, moving downwards. Now voltage increase. This is speed decreases. Right. So at a particular voltage it will be a crest, and again beyond if I increase it will move upwards. Charged particle, clear about the point. Initially due to gravity it is moving downwards at voltage zero, first point. Now voltage increases, what will happen? So speed decreases. Speed decreases. At a particular voltage it will come to rest. Beyond if I increase the voltage, it will move upwards. Now what they did, they applied a particular voltage. They applied scientists. They applied a particular voltage or at a particular voltage. At a particular voltage, so still more forces are there. Try to understand. Basic part I am telling. Still more forces are there. Why? This is fluids. Buoyancy force will be there. Viscous force will be there. Slowly I am getting into the topic. Don't worry about that. Just the basic part I am telling first. Now, how they did that experiment, how they got the magnitude of the charge. If you understand this, then I can increase the level such that you can understand everything. Right? So now I am not considering the buoyancy force and viscous force. Just the basic idea what they did I am giving you. Right? So at a particular voltage, what happened? Electrostatic force and as well as gravity got the same value. So in a sense balance. If they balance, might be at rest or they can the drop can move with terminal velocity. Point is important. So forces are equal in the sense body can be at rest or body can move with constant speed. Right? Both possibilities are there. We'll see later. Okay. So now, what I can tell? So electric field and as well as gravitational force will be same. Now try to write something. So electric field depends on what? Electric field depends on what? And the gravity depends on what? Right? So electric field depends on. So force of electric field depends on what? And the gravity depends on what? Gravity depends on mass. And G is there, okay? Don't worry about that. That is a constant. It depends on mass. Right? So now QE, it depends on, we know the formula QE, which is equals to mg. Okay, right, mg. So QE, which is equals to mg. So how much voltage we apply and what is the distance between the plates we know. Yes or no? So how much field we can calculate or not? Why? Because voltage we know and the distance between the plates we know. So that's why electric field also we can calculate. What is the relation? E equals to V by D. So we know the relation. So we can calculate electric field. We can calculate electric field. It depends on the potential. So potential we only varied. We know that. Right. So mass of the drop. So we are only sending. So here how much gap is there we know. So one drop, how much mass it will be there we know. It's an experiment. So they have drawn a tabular column. Mass of the drops or mass of the each drop and voltage applied. Clear? Try to understand the point. Mass of the each drop and voltage applied. Mass of the each drop and voltage applied. They consider different masses of the drops. So first, for example, very small drop. So they calculated and voltage how much they applied such that this condition is satisfied. They did and they have written. Next, another drop of different mass. Then how much voltage? Like that, they did this experiment. Okay, so we know E, we know M, and we know G. We can calculate the charge or not. So now, finally, by using this relation mg by E, they got charge column. Mass of the drop, voltage applied, then charge on the drop. They got for a particular very small mass of the drop and how much voltage applied. After that, they calculated that charge, corresponding charge of that drop. They got, for example, plus 160. Try to understand the point. Okay, right? 160 better. Okay, so consider it as 160. Right. So for what we got? Mass of the small drop and how much voltage applied and how much charge we got? 160. Next, another drop they considered little bigger mass and voltage they applied and they got the charge as 320. It happened. It happened at the time of this experiment. It happened. So still mass increased. They increased the mass. Applied voltage also should increase. Then they got 480. Next, again voltage. Again it's you understood I think now after writing 3. So 480 plus 160, 580, 640. Then next mass they varied, voltage applied. Then next how much? It is 800 and so on. They got the charge like this. After getting like this, the charge will be 2 more or will be 2 less? Will be 2 less. Why? Because mass of the drop, what we can say is 2 less. So the charge also 2 less in the form of zeptocoulombs. Zeptocoulombs. Zepto 10 to the power minus 21. Zeptocoulombs we call. So that is in the order of 10 to the power minus 21. Very small. Okay. So understood the point? They considered a mass, voltage varied, got this. Next, another mass, voltage varied, they got this, and so on. Continue. Now, these scientists they sat and they are thinking, okay, now we know. At that time they are thinking about this is the multipliers of 160. In the sense they have written like this. It is 1 into 160. 2 into 160, 3 into 160, and so on, and so on, by question, and so on. So they have written like this. In the sense, what they are thinking is, so 1 into 160 in the sense, it's of 1 electron. Try to understand. It's of what? One electron. Q equals to Ne. We studied. From where we got that? From this. Everything is related. We divided into different chapters and we are studying. But as a whole, you have to study like this. Right? So 1 into 160, 1 electron. Right? So what is the charge is there on the drop? When you got the charge like 160, it's of 1 electron for that drop. Next, mass varied, voltage varied, and they got 320. In a sense, what is the charge on the drop? 2 electrons. 2 into 160. Next, mass varied, voltage varied, then what is the charge? 3 into 160, and so on. So it happened. Practically, it happened in this experiment. Then they came to know, okay, so if it is 160, we can write 1 into this, 2 into this, and 3 into this, and so on. So finally, that should be the order of how much? 160 zeptocoulomb. So 1 electron, in a sense, what is the magnitude? Can you write this now? So very interesting modern physics if you study like this, or else we can complete the syllabus according to your NCERT. So don't worry about that. We can complete modern physics in a week. If I tell NCERT, in a week. No, not more than that. Try to study everything. Okay? So 1 into 160, 2 into 160, 3 into 160, what do you mean by that? What do you mean by that? So 1 into 160 indicates 1 electron. 2 into 160. On the drop, how many electrons are there? 2. 3 into 160. 3. So they finally concluded that 1 electron, which is equals to, so minus is the sign we know, negative charge electron. So I have written it as minus. So how much is that? 160 zeptocoulombs. 160 zeptocoulomb. So zepto minus 160 into 10 to the power minus 21, and this will be 21, 20, 19. So 1.6 into 10 to the power minus 19 coulomb. So this is the magnitude of 1 electron according to the experiment. What they did? So they consider oil. Why only oil? Why not water? So water in the sense, if I apply to any X-rays or so we have to get that particles ionized, charged. So for that we have to apply some process. So I consider X-rays, different process will be there. Don't worry about that. So by applying different process on that liquid, whatever it may be, on that liquid should be there first. That liquid should sustain that process. For example, water, X-rays, very high energy, it will be evaporated. It will be evaporated. No water molecules only. If there is no water molecules, then how to see the charges and all, and how to perform this experiment? We can't do. So that's why water and all we can't use. We have to use the oils, non-volatile substances, I think we call. So we can consider a particular density of oil, not all the oils. Particular density of the oils according to the experiments, right? So without applying the voltage, only gravity will act. Now we have to vary the voltage in such a way that the forces should be equal. Then we know the field, how much we applied, we know mass, we know gravity. This is the basic thing that what you have to understand, how they calculated the magnitude of the charge. Basic thing I said. Now we will go in depth. We will try to calculate the formula of the charge. That will be very important. If you understand this, I think how you got this magnitude, you can understand what they did. This is the basic story, what they did. Not exactly, basic story. But here some forces I neglected already, I said. Now we will consider all the forces and we will try to calculate the formula of the charge. Right? Clear about the point up to now what we did? Okay? Now, actual thing we will discuss. So, basic thing, I said that I calculated the things according to them. Okay. Now, actual thing, if we discuss about the experiment, try to think. Here, drops are there. Drops are there. Okay, right? Very good. So, drops are there of negative charge. I am not changing the things. Now, consider a drop. Consider the same drop what we considered the last thing. Consider the same drop of negative charge. Tell me how many forces actually acting on the drop. That is important for us. Actually, how many forces are acting? Try to write all these points in the note. Actual thing is done. Try to write in the note. These formulas are very important, right? So now consider a negative charge in the particle. Again, the same negative charge I am considering, but all the forces we will consider. So tell me. So gravity acts, we know, right? So if gravity acts, the particles are moving downwards. Particles are there in the sense buoyancy force will act. Buoyancy force in which direction will act? Buoyancy force, fluids. Buoyancy force will be there, which is acting upwards. Okay. So gravity, buoyancy force. Now assume now electric field is not applied. First case. Potential is not applied. Right? First case I am doing like potential is not applied. So Fg downwards, buoyancy force upwards, and in which direction the drop can move? Downwards. So if the particle is moving downwards with some velocity, that velocity we call as terminal velocity. Try to wait for a minute, okay? So gravity acts downwards, buoyancy force acts upwards, and definitely that gravity should go downwards, right? Because gravity will be more. It is moving downwards, okay? So it is moving downwards. One more force also will act on the drop. What is that force? Air drag. So, for example, you are going in a bike. You are going in a bike. Wind in which direction it will be? In the opposite direction of you. Yes or no? So wind force. So if you are moving in a bike. So wind force in which direction will be opposite to you? Always the resistive force. We call it as resistive force if it is normal mechanics. Here we call it as viscous force. Now if a particle is moving downwards, a drop or any fluid particle is moving downwards, in which direction viscous force will act? Opposite the direction. For example, the particle is moving upwards, viscous force acts downwards. Not in the same direction always. It depends on the speed direction. Okay, depends on the speed. Direction of the speed, right? So it is moving downwards, viscous force will act upwards. So Fg will act downwards. Clear about the point? Now, generally, gravity will be more. We know that. Now here, how many forces are acting? Two forces are acting. One is buoyancy force and one is viscous force. Now, at a particular point will come such that a constant velocity will be attained by that drop. Try to understand. How it depends on viscous force? How? We know a formula. Try to remember this formula for viscous force: 6 pi eta Rv, where V is terminal velocity. So what do you mean by that viscous force? Resistive force, I said. Now try to understand it practically. So you are going in a bike with 20 kilometers per hour. What will happen to resistive force? Will be less. Go with 100 kilometers per hour. So resistive force increases or what? Resistive force always depends on the velocity of u in opposite in the direction. Whether it might be in fluids or it might be in the normal mechanics situations. But constants will change. Air resistance, that value will be different. Fluid resistance, it depends on viscosity and all. Right? So, but the major relation will be same. Resistive force depends on the velocity. But here, how many forces are acting? You have to understand this point. So that's why I'm wasting more time here. Okay. So two forces acting upwards and gravity acting downwards. At a particular point, it will come where the drop will move with a constant velocity. That constant velocity we call as terminal velocity. That constant velocity we call as terminal velocity. So if a drop is moving with constant velocity, in the sense what? Net force 0. So net force 0 in the sense Fv plus Fv equals to Fg. So who is balancing gravity now? Buoyancy force and as well as viscous force. This is the actual story. That's what you have to understand. Clear about the point? So buoyancy force plus viscous force, which is equals to gravitational force. So when you have to write like this, that drop should go downwards with constant velocity. That velocity we call as terminal velocity. So what I can write now? Fb plus Fv, which is equals to Fg. First equation. Now buoyancy force, I think you remember the formula. I think so. Buoyancy force formula: V, rho and G. V, rho and G. Volume of the drop, density of the drop, right? And G. Clear about the point? Right? So now, buoyancy force. So tell me what I can write. V, rho and G. What is V? Volume. Volume of the drop. 4 by 3 pi r cube. And what is rho? Density of the drop you have to see, or density of the surrounding we have to see. Try to understand about the buoyancy force. Consider a container with liquid and consider any substance inside. Okay, so mg acts downwards and buoyancy force acts upwards. So buoyancy we call it as V rho G, but of the substance or the surrounding material. So surrounding liquid, so density of the liquid we call. So here mg also we can write as V rho G, but what is this rho? Rho is density of the substance. It will take little time to understand, don't worry, but try to understand it. In this chapter, apart from this, nothing is there to discuss. It will be easy for you, right? So mg V rho G, V is volume of the substance, density of the substance into G. So buoyancy force, volume of the substance, why? Because it is completely immersed. So density of the liquid into G, right? So liquid in the sense here there is no other liquid, so I will consider the density of the air surrounding. What is that? Air. So 4 by 3 pi r cube is the volume of the drop, and the density of the air, write it as d dash or rho dash, whatever density, and G. Plus viscous force, we know the formula, what is that? 6 pi eta r v, which is equals to what? Fg. What is Fg? Mg. Fg is nothing but Mg. Mg is nothing but, again I can write it as 4 by 3 pi r cube. Now density of the drop I am writing it as d and G. So if you want clarity, try to write down d dash, density of the surrounding. So d, density of the drop. Okay, so density of the surrounding actually. Okay, not a problem. So density of what? Density of the drop. So this is equation 1. When these all the things we discussed, when the voltage is not applied. Now we'll apply the voltage and try to write the equation and solve the two equations, we'll get the answer. That's it, simple. So now case 2. Is it clear about the case 1? Voltage not applied, gravity is acting down, and another two forces will act upward. So at a particular situation, the drop will move with a constant speed. So it is moving with a constant speed. We call it as terminal velocity. Constant speed in the sense forces will be balanced. With that, I have written an equation. Right? So next case 2. Voltage is applied. Voltage is applied. Now see here. Voltage is applied. If voltage is applied, what will happen? Electric force will be there on the charge, right? So draw the diagram, three-point diagram again. So draw. Show the forces. Gravity down. So now electric force applied. In which direction that force will be there? On the negative charge. Electric field downwards. Negative charge in the sense that force will be upwards. So this is electrostatic force. Now buoyancy force always acts upwards. Now what will happen to viscous force? Now I am rising, consider, I am rising the electric field in the sense potential in such a way that the drop should move upwards with a constant speed again, same speed. So I calculated this speed and I got some value. Now I am varying the potential in such a way that the drop should move upwards with this same terminal velocity. In such a way that we applied the potential. Right? Now the drop is moving upwards with the same terminal velocity as like in the first case. Now direction is reversed. Terminal velocity Vt. Same velocity V. It is moving upwards from above. What is the direction of the viscous force? What is the direction of the viscous force? It is acting downwards. Right? Viscous force always depends on the motion of the body. Motion of the body in positive axis, in the sense viscous force will be negative. Motion of the body negative, viscous force will be positive. Resistive force should be opposite. Right. Now the drop is moving with a constant speed, but the direction is reversed in such a way that we have made the potential. Now what I can write now? Buoyancy force plus electrostatic force, which is equals to viscous force plus gravitational force. So buoyancy force, electrostatic force, viscous force, and as well as gravitational force. So these two are balancing each other such that the drop is moving upwards with a constant speed. Constant speed in the sense net force will be 0. So this is the thing. Now try to substitute all the values and try to solve 1 and 2 equations. We'll get the challenge. Right? So write the equation. Write the equation. Buoyancy force same. Right? Buoyancy force same. So 4 by 3 pi r cube d dash into g plus electrostatic force QE. Yes or no? Charge Q and E. Magnitude I can say. Don't worry about that. Right? So which is equals to viscous force 6 pi eta RV and plus what is the other thing? So it will be plus here I am writing here. Okay, so this is plus 4 by 3 pi r cube d and g. So this is equation. Nothing difficult, but don't worry about this. It's not that much difficult. I think so. It's clear about the point. First case, voltage is not applied. Gravity will be more. So it is moving downwards. If it is moving downwards, speed increases. If speed increases, resistive force increases. So at a particular point will come, there the terminal velocity will be attained by the drop. That is the story, right? So with that. Next, here no need to tell any story because electric field applied by the potential varied, so it will move upwards in that speed. How much speed we want, that much speed we can give to the drop by varying the voltage, right? So this is the thing. So now solve these two equations. We can calculate Q or not, right? So how to solve? Subtract the two equations. What you will get, we will see. Subtract the two equations. Done, almost done. Don't worry about the things. So try to understand these two cases. Remaining cases also possibility will be there. Alright. So how much electric field applied such that the particle will move upwards. So we can calculate from this or not. How much electric field applied such that the particle will move upwards with the terminal velocity. From this equation only we can calculate that. Add the two equations, what we'll get, we'll see. So add or subtract. So if you subtract these two equations, these two terms will be cancelled. Yes or no? So we'll write again. So first equation, 5 minutes, it will be completed. So 4 by 3 pi r cube d dash g plus 6 pi eta rv, which is equals to again 4 by 3 pi r cube d g, and now again 4 by 3 pi r cube d dash g plus qe, which is equals to 6 pi eta rv plus 4 by 3 pi r cube d and g. 1 and d. So solve minus. Can I multiply with minus there? No problem. What nonsense, right? So this will be cancelled. And any more cancellations? See here 4 by 3 pi r cube dg positive and 4 by 3 pi r cube dg negative. What? Right? So what I can write 6 pi eta rv. Yes or no? So minus qe, which is equals to. So this R is what? Here we have written capital R. In the sense this will be also capital R only. Yes or no? So wherever I have written small r, please change that. Why? Because this radius of the charge a drop, and here radius will be same. Radius will be same. Anywhere? Yes. So here and here, right? So 6 pi eta rv minus qe, which is equals to minus 6 pi eta rv. Clear about the points? Is that okay? So this is about QE, where I can write QE will go that side and this will come this side. So this will be 6 pi eta rv and plus 6 pi eta rv. So this is the charge. Right? Now R value we can calculate from here. See, both the values are same. 6 pi eta RV, 6 pi eta RV. We can add these two. So QE, which is equals to our charge if you want. Electric field will go that side. So it will be 6. So it will be 2. I can take common 1 plus 1, 2. So it will be 12 pi eta RV divided by electric field. So some functions, radius is there. How to calculate this radius in the sense directly? They won't give the sense. You can calculate from this. So directly if they give, well and good. So if they didn't give directly, you can consider the equation 1 to calculate the radius. So this is the formula to calculate what? To calculate the charge. Is that difficult? I don't think so. First equation we can write, second equation we can write, and we can add the two and we will get the things. Right? So if the terminal velocities are same, then we can do like this. One more point. Try to understand one more point. In my view, I did this. So some cases will be there such that the terminal velocities might not be same. Terminal velocity attained, but terminal velocities might not be same. No. So this is my situation I did. So terminal velocity, I assumed it as for both the cases it is same. But there won't be any such situation that terminal velocities can be same. It can be different also. Terminal velocities will be the constant velocity, right? So I assumed both are in both the cases it is same, so I did. So case 2, if terminal velocities are different, so V and V dash. Clear about the point? V and V dash. In the sense, in the first case it is V, and in the second case it is V dash. Now the charge will be equals to 6 pi eta. So first what will get? V, right? Next this one will be V dash, and QE will go that side. This term will come this side. Yes or no? So it will be V dash. Clear about the point? So it will be minus will come this side. That will be V dash. Right? So now what I can write? QE will go that side. That will come this side. So 6 pi eta R V plus V dash. Chances will be there. Don't worry about this. Right? See the calculation part. RV, this one. So 4 pi D plus QE. Right? So this one 6 pi eta R V dash. So I consider it as V dash. So don't be confused. Write it as case 2. Pause the video previously and write it as case 1. If terminal velocities, if it is same, then you can do. If it is not same, then you can consider this terminal velocity is V, this terminal velocity as V dash, and we can calculate that. Right? If radius if they give directly, you can substitute. If radius if they didn't give directly, then see the equations according to the given question, we can calculate the radius. See from here, we can calculate the radius or not. Right. Next point, calculating the radius. Calculating the radius of the drop. How to calculate the radius of the drop? Radius of the drop from equation 1. From equation 1. So see, R terms one side, remaining terms flow to the other side. Clear about the point? So now this term can I send to that side? So it will be 6 pi eta RV, which is equals to this term. I have sent to the other side. So take 4 by 3 pi R cube and G common. So what I can write? D minus D dash. So cancellation 1 R will be cancelled. Now square will be there. So 2 2s, 2 3s, so it will be 9 by 2, right? So we can calculate R or not. So therefore, R which is equals to 9 pi eta. Yes or no? So 3 came this side, so 9 pi eta V divided by, clear about the point? It depends on again the terminal velocity in the first case. So 9 pi eta V divided by, so 2 pi also will be cancelled. Right? So it will be 2 and R square we are calculating. So G into D minus D dash. So this is R square, right? So it will be square. So if they give radius directly, okay. If they didn't give radius directly, by considering the terminal velocity and the difference in the densities, we can calculate R. So need level, I think chances are there they will ask radius or they will ask some cases like this. You are in a stage to write the equation, then it will be easy for you. Now, We'll close this topic, we'll revise later and we'll close this topic. What we discussed? So first J.J. Thomson, yes or no? So J.J. Thomson, what he did, so he discovered electron, but he forgot in the sense he did some experiments, but he can't find the magnitude of the charge. For that, who came with the experiment, oil experiment, who came with that? Milikan as well as Fletcher. So what they did some experiments, they calculated the magnitude of the charge. First they applied the voltage, second they didn't apply the voltage, they got some terminal velocities, might be same or might be different, generally it will be different only. So in my assumption I did for you a better understanding, generally the terminal velocities according to me it won't be same I think, right? So some chances, there is less chances are there it will be same, it might not be same, so that's why second case will be important, right? So now if here divided by E is there, don't worry about that. So here another case divided by E, right? So don't worry. So calculation part you can understand. Try to understand these first two equations properly. Remaining things I think you understood. Oh, right? So the charge we can calculate if radius if they give directly okay, or else that radius also we can calculate. Radius also we can calculate. It depends on the terminal velocity without applying the voltage. So because we consider the first equation to calculate the radius. Clear about the point? So this is the way the scientists did the experiments to calculate the charge. Clear? Right. So this is about the oil drop experiment done by Milikan as well as Fletcher. What they did, everything I think we tried. Right? Next. After J.J. Thomson who came, that we have to discuss now, right? So now, after J.J. Thomson, Rutherford, very important experiment he did, very important for board level too. This is not that much important for board level, don't worry, but you have to understand how the charge, a magnitude came and all. So that we discussed all these things. So next, very important for board level now. Very important. So, who came after J.J. Thomson? Try to learn in an order. Dalton, J.J. Thomson, now Rutherford. So, Rutherford's alpha ray scattering experiment. Next experiment, scattering experiment. So, next experiment. So what he tried to do, that we will discuss now. Okay, so 10-15 minutes, I think, easy experiment. Okay, so what he tried to do, I think in chemistry his name is very famous. I think why? So Rutherford, what is the final thing he did? He discovered nucleus, right? So before discovering nucleus, what he did? That is this experiment. So finally, what he did, I said. So what he did, he discovered nucleus, and the radius, the size of the nucleus is about in the order of 10 to the power minus 15 to 10 to the power minus 14. So all these things given by the Rutherford. So how he gave, what is the experiment he did, and what are the observations, what are the results, everything we have seen, we have to see in this experiment. Clear about that? So for that, what he did, start again, one more experiment. So for that, what he did, we have to discuss. Right. So he considered a source. Concentrate again, another experiment. So come back out of that oil drop experiment. Come back out of that and listen this one. So no relation between that experiment and this experiment. So okay. So he considered a source. Okay. So that source will produce you the alpha particles. What is the source he considered? He considered a source. Assume that is a source. So source. Okay. So this source continuously produces alpha particles. Assume it produces alpha particles. Alpha particles. So what particles? Alpha particles. It produces alpha particles. What do you mean by alpha particles? So alpha particles, try to understand. Alpha particles is nothing but a helium nucleus. So what is helium? 2He4, I think we know. So 2 protons and as well as 2 neutrons. This is of positive charge. Positive charge, and what will be the charge? 2 times of 1.6 into 10 to the power minus 19, right? So and mass, it will be of 4 times of the mass of the proton. 4 times. And 2 times of the charge of the proton again, positive charge of the particle. So this we call as alpha particle. Try to remember, very important. Alpha particle, always it will be of positive charge, and the charge compared to proton will be little more. So how much? It will be double, and the mass, if you want, it will be the 4 times that we will discuss in the nucleus chapter. How it will be 4 AMU, we call atomic mass unit. So all the things we will see later. Okay. So try to remember. Helium nucleus, we call it as alpha particles, positive charges. Now we are studying that alpha particles. Right. While studying, what I did is I placed lead bricks. So I placed okay. So what are those? Okay, lead bricks. Lead bricks, isn't it? Okay, so lead bricks. So at the bottom also, so is that clear about this alpha particles? So I want that space. Why? Because only a small gap should be there between the lead bricks. Okay, so still more are there, just I have written 2. So what is the use of the lead bricks is whenever they are very strong. Lead bricks, why only lead bricks? They are very strong. In the sense what? If for example alpha particles will go only in that direction, no. In sources in the sense alpha particles will go in all the directions. If alpha particles will go in all the directions in the sense, we don't want, in the sense he don't want that alpha particles should go in all the directions. Alpha particle should go in one particular direction in a beam. Beam in the sense a number of charged particles, a bunch of charged particles should go in one particular direction, not in all the directions. So what we have to do? We have to restrict that. So how we can restrict that? By placing the lead bricks. By placing what? By placing the lead bricks. Clear about the point? So by placing the lead bricks. Now the alpha particle, so here lead bricks are there. So we decided the path of the alpha particle, they are going straight. Now on the way we placed a very thin gold foil. So what is this? A very thin gold foil. Very thin, in the order of 10 to the power minus 6 to 10 to the power minus 8 meters, a very thin gold foil. So this source, around, according to your NCRT, this source will produces energy around 5 mega electron volts to 7.7 mega electron volts. This source will produces energy in the order of 5 mega electron volts. What do you mean by mega? It will be around 10 to the power 6 electron volts. 5 into 10 to the power 6 electron volts to 7.7 into 10 to the power 6 electron volts. That much energy that alpha particles, with that energy alpha particles are coming out. And we can say gold foil, very thin gold foil. Why only gold? Why it should be very thin? In a sense, he is doing some experiments on the atoms. He is doing some experiments on what? On the atoms. So, right. So, while doing the experiment on the atom, why only gold foil is? Gold we can divide into very thin particles we can divide in the order of one atom. If I consider this sheet, so what type of sheet he considered with the gold is, he considered only one sheet of the gold foil. On that sheet, only one atom is there. One atom in the sense a series of atoms of only one atom is there. If I see back, no other atoms are there. Only one atom of the thickness. Only one atom layer you can set. Another atom layer is not there. So that much thin we can make by the gold. So that's why you can set that gold foil. This is the order of 10 to the power minus 6 to 10 to the power minus 8. Understand? Only one atom is there on that layer. Another atom is not there. So that much thin he can set for the gold. Alright. So now what happened is this alpha particle after striking the gold foil, what will happen? It will deflect. So why? Because alpha particle positive charge and an atom is there in the sense we know that. I am telling what we know, what he did we will see. Okay. So atom is there in the sense inside the atom nucleus will be there. So now what will happen? Positive charged particle and assume inside the atom nucleus is there, that is also positive, and the positive charged alpha particle is coming. What will happen? Positive attractive or repulsive? Repulsive. So in all the directions these alpha particles will be deviated or not? Reflected or not? So to find the deflection, what to find? To find the deflection, he considered a circular screen. Circular screen. What he considered? He considered the circular screen made up of the same zinc sulfide. Made up of zinc sulfide. Clear about the point? Now after striking the alpha particles, after striking the gold foil, then what will happen? It will deviate in all the directions, right? So it will deviate in all the directions, So it's like this, not like this, right? It's like this. After striking, what will happen? It will deviate. So it will deviate in all the directions. So assume it's deviated. After this will be in this direction. So according to NCERT, they consider a circular screen, I think so. So why circular? So it can deviate in this direction also. It can deviate in this direction. It can deviate in that. It can deviate in this. So you can make it as a circular screen. Better. Right? So circular screen. Right? Better. Why? Because so after striking, chances are there that the alpha particle can deviate in this direction. Yes or no? So can deviate in any direction. So only one direction I am showing. After striking, it can deflect in any direction. Right? So this is the experiment what he did. So after deviating, what will happen? It strikes on what? It strikes on the screen, zinc sulfide screen. What will happen after striking? So we can see a spot. Yes or no? We can see a bright spot there. That is the specialty of the zinc sulfide screen. Already we know that. So now to observe that, what happened? So he connected a microscope to this zinc sulfide screen. So he has sent some alpha particles and he is moving mobile microscope. Mobile. So he is moving through this microscope. And he is moving and he is watching through the microscope. Now what finally he observed, we'll see in the next class. Okay. So what finally he observed, we'll see in the next class. Is that clear about the point? Source, I think the source is type of bismuth. Different materials you can insert, but he can set this up, which is of the suitable energy required, right? So 5 megaelectron volts to 7.7. So after striking, what happened? It deflected. Now, what he observed, we have to see the observation. So in the next class, I won't draw this diagram. I will continue with the observations, try to draw this and try to see this in the next class. I will write only the observations, right? What he observed actually is, try to understand the point. What he observed actually is, here gold foil is there, in the sense an atom is there, only one atom. Try to consider one atom. Now alpha particles are going. If for example 1000 alpha particles if we send, in that 1000, how many alpha particles are deviated and how many alpha particles are not deviated? How many alpha particles are deviated and how many alpha particles are not deviated? He has given those all observations. What is the first observation is most of the alpha particles are undeviated. Many more observations are there. Most of the alpha particles are undeviated. A very less amount of the alpha particles is deviated by greater than 1 degree. Greater than 1 degree by using all these things. Greater than 1 degree, how many number of alpha particles deviated? Greater than 90 degrees, how many alpha particles deviated? Or how many alpha particles retraces back? How many alpha particles retraces back? So how we can calculate that by using a formula? And what do you mean by impact parameter? Now I think it's of NCRT. You can understand everything. Is that clear about the point? Alright. So try to draw this diagram properly. In the next class I will draw. We'll see the observations and we'll continue. Right? Thank you. Bye.
Topics